Hi, I am Ali Nabhan Abu Bakr from the Villa College Mays in 2023 Bachelor's UV batch. I will be presenting to you my business analytics technique NPV, also known as net present value. NPV promises that your project will give you cash in the future as long as the final calculation value for it remains above zero. The intuition behind NPV states that money right now is worth more than money in the future because you can spend it on whatever you want right now compared to money that you will have later. The formula for NPV is actually the inverse of the interest formula, with the negative value taken as the initial investment, added with any number of CF cash flow values over a selected period of simple t time, divided by the discount rate R. The number of cash flow values taken depends on the capital T, the number of years, days or months you took for the simple T. So the cash flow and discount rate are dependent on a multitude of factors such as the cash flow formula presented as subtracting revenue, costs and task while adding the depreciation value and subtracting the total with capital expenditure or capex, and finally adding or subtracting the working capital. I will now present to you an example of NPV with an initial investment of $1,000. You take a discount rate of 1.1 with an increasing measure of yearly time being to the power to each discount rate, right? You add all those together, totaling 1175.61, and subtract with the initial $1,000, getting you the final value. Hopefully it should be above zero if you want your project to succeed. To remind ourselves of the cash flow formula once again, before even starting on the NPV, we can look here, a repeat of what I already explained about calculating the cash flow. So to calculate the discount rate, there are actually two methods. We can use the WACC, or weighted average cost of capital, if there's no external factor such as a risky economy or politics involved. Otherwise, dependent on expectations, you can increase the value you get from the WACC and use that as the discount rate. So let's discuss the pros and cons of NPV. It is actually a good method to show your investors and stock stakeholders that your project will get you a profit, although it depends on the discount rate you choose. If it's too high, your NPV value may reach zero and below. Now, if you're going to be using NPV, there are some common pitfalls you should try to avoid. Things such as mixing the cash flows and discount rates with and without interest. So, like in this diagram, you can see the initial cash flow being minus 1,000, because and then it climbs up back up each year due to the increase in simplicity time. So in this diagram, this graph we can see that the NPV is actually proportional to the discount rate. The higher the discount rate is, the lower the NPV value in the final calculation will be. There's something called the IRR. Okay, and this is exactly when the NPV reaches zero, the exact point. So there are some differences between IRR and NPV. So NPV gives the answer in money today, right? Well, IRR gives the answer as a percentage return. NPV uses a discount rate chosen by you by IR, but the IRR, internal rate of return rate, it finds the discount rate that makes NPV like equals to zero, that exact value. So NPV is more reliable for choosing between projects, while IRR can be misleading when the projects have different cash flows. Now I will introduce to you something called payback period, which is a different method. It answers one simple question, which is how long until you get your initial investment back. How many years it takes. It ignores everything up to that point, after that point. So in this slide, I'm putting all three methods together using one simple project, right? And so you have $1,000, then you receive $600 each year for 2 years. For the payback period, right? You ask how long until you get your $1,000 back. After 1 year, you got $600, right? After two years, you'll have double that. So you recover your money in less than 2 years because of 1,200, and the cutoff point is $1,000. So for IRR, we look for the percentage return that makes the project break even with the NPV terms. We get an IRR of about 13% per year. Now for the NPV, we use a 10% discount rate and convert the two like cash flow inflows into today's money. Then we discount the two $600 payments and subtract the initial $1,000 investment. The NPV is about $41 in today's money. Okay, that's it. Now here are the references for my project. Okay, that's it. Thank you very much.